What's up, kids? Lesson 3 homework is really an extension of like our knowledge from lesson 2. How displacements tell us about motion. And displacements are areas under velocity. Areas under derivatives tell us how much something's increasing or decreasing. And we are going to talk about finding, for the most part, max and min positions. When am I furthest right, furthest left? Well, what's important is that, a max and a min, if it's a closed interval, could be at an endpoint. And this is important to just think about motion, I could start or end at a place that's furthest right or furthest left. And this is going to be like for functions. Like I could have a dude who literally starts here, goes to the right some, goes to the left some. This would be considered like a relative max because I changed directions. This would be considered a relative min because I changed directions. But maybe like where I start and where I end is my furthest left or furthest right. Okay. Or like vice versa. Now, maybe we have a situation where uh, the dude does go really far to the right, comes back a little bit, and then ends up somewhere in between. Yeah, well, then, like, when I change direction, when my velocity is zero, when my derivative x prime is zero, I'd have a max, but I could still have an endpoint be a max. Do we always need to check endpoints to find extreme values? Not necessarily. And I hope this makes sense why it's not necessarily. For example, if you want to figure out when something's furthest right and your velocity is positive and negative, could your endpoint here and here be when you're furthest right? Well, no, because I start somewhere, I move to the right, and then I move to the left. How much? I don't know, but I move to the right and then I move to the left. Maybe a little bit less, maybe more. But no matter what, boom, this has to be the max. Okay? Now, if I don't have a calculator, how am I going to do this? Well, you got to understand the motion. You got to understand your velocity. You got to take the derivative and set it equal to zero. That's how we find our max and min. Goes back to ff prime, f double prime. Take the derivative. Okay, it happens to be velocity. Set it equal to zero. What we are doing is we are examining motion, changes at 3. X prime, which is v, is negative than positive, which means x is decreasing than increasing. You could apply this to f's and f primes, guys. Or my guy is moving to the left and moving to the right. So I know for a fact x of 3 has to be when I'm furthest left. I started somewhere, I move left, I move right. No matter how much I move left or right, this right here has to be when I'm furthest left at 3. Now, I don't have to confirm it. It doesn't ask me what my position was, but if I wanted to, I would just plug 3 back into the position. 9 minus 18 plus 2 is negative 7. Okay? Now, when am I furthest right? Well, you could think, oh, between 1 and 3, that's more than between 3 and 4, but you got to be careful, okay? It's not safe to do that. Just go ahead and just compare. It's either going to be at the start or at the end. At the start, I'm at 1 minus 5 plus 2, which is negative 4 plus 2, which is negative 2. Or at the end, 16 minus 24, which is negative 8 plus 2, negative 6. When am I furthest right? Actually, at a position that's negative. That's fine. I start at a position at 1 at negative. Wait. I did this math in my head. 1 minus 6. I already wrote 5. My bad. I start at a position of -3. I then travel to the left to a position of -7. I then travel to the right of 6. Like, this is it. This is it. This is really how we're going to go from F prime to F eventually. Just if you just have V and you can find like the areas under V, if you just have F prime and you find the areas under F prime, you'll be able to get F. All right, let's look at this guy. Take the derivative, set it equal to 0. It's the same stuff. Oh, this is annoying. Whatever. Add 4 divided by 3. We'll get plus or minus root 4 over 3, which is 2 over root 3, which is 2 root 3 over 3. Whatever, just leave it like that. The only one I care about is the positive root 4 over 3 because we're talking about an interval from 0 to root 4 over 3. Sign check. I don't know, plug in like 0.0001. 3 times that is going to be very small. Subtract 4, it's going to be negative. You're going to change, are you going to change signs? Yeah, you'll change signs. Plug in 2.999, something close to 3. If I plug in 3 squared is 9 times 3 is 27 minus 4. You can plug in 2 there. All right. Same deal here. I'm moving left. I'm moving right. My position is decreasing, then increasing. So furthest left, obviously, is going to be x of root 4/3. I'm not going to find that. Whatever that equals, whatever, great. Furthest right, it's going to be either 0, 2, 0, 3. I wonder if I wanted that to be t squared. All right, 27 minus 12 is 15. Furthest right at 3 again. I'm freaking myself out here. I started at -3. I go down to get to -7, and then I just go up a little bit to get to -6. Yeah, here, other endpoint. I started at 0. I go left or down to get to this point, wherever it is. And then I go right. I end up going more to the right than I go to the left. So the other endpoint. This is a good question, actually. So we could say, oh, left endpoint, right endpoint. Depends on the situation. All right. Take the derivative. Set it equal to 0. We've done this so many times. Let's do a sine analysis. We got 0 and 4. We're going between 0 and 5. Here's V. It's going to be positive. It'll be negative here. Moving left, moving right. Again, I don't like how all of these are moving left or moving right. My bad. My apologies. It won't always be like that. I wish I gave you better examples. X of 4 obviously is going to be when I'm furthest left. It's 4 cubed minus 6 times 4 squared, wherever that is. When am I furthest right? It's either at 0 or at 5. 0, 0. X of 5 is annoying. It's 125 minus 25 times 6. Oh, jeez. 15. 125 minus 150, so -25. So I must go left a lot. Furthest right here, furthest left here. All right, V is t squared minus 6t plus 8. Guys, I can't tell you how many times I see people mess this up. And they're like, put these numbers here, but they don't know which one's for which. And they're like, oh. And they like find the two numbers that multiply to get -6 and then add to get 8. It's not. It's the two numbers that multiply to get 8. Think about what you get. T plus times t plus. What's going to happen when you multiply? This number times this number gives you a number. -4, -2. All right, now this is a great example here because we have two sign change locations in our interval. We got 0, we got 5. We're talking about 2 and 4. If I did a sign analysis, it'd be positive, negative, positive, and this is my velocity telling me my position increasing or decreasing, or if we want to skip the increasing, decreasing, we know that if my position is increasing, I'm moving right. Now, this is where we have the concept of a candidate. We got derivative equals to 0, we got endpoints. But let's talk about like which one for which. When am I furthest left? Well, I start somewhere, I move to the right, then I move to the left, and then I move to the right. Where could I be furthest left? Well, when I change directions from moving left to moving right, when I change directions from moving left to moving right, right? This could be the location where I am furthest left. But if I start somewhere, I move to the right, and then I move left and move right, maybe the starting point, if you move right, could be the minimum location. Literally, I can come up with two candidates just right off the bat. Now, I'm going to get my calculator out for this because it's annoying. Because I don't want to have to do this math. X of 0, fine. X of 0, that's my candidate. X of 4, I don't want to do that. X of 0, 0, X of 4, whatever this is. 1/3 times 4 cubed. Minus 3 times 4 squared. These aren't the most important ones that we're going to be doing. 8 times 4, 5 1/3. Now, my candidates when I'm furthest right have to be when I go right to left or end up, going to the right. So X of 2 and X of 5. And I'm just going to find this real quick. I wouldn't give you stuff like this where like the arithmetic is just annoying. Six and 2/3, X of 5. Look at that. There's two locations that are furthest right. Cool. All right. Now, what is a velocity at maximum? This is where things get complicated and people mess up. Okay, so Vmax. So what I need to look at is when V, changes, like goes from increasing or decreasing to increasing, right? Because then it'll be a max or a min. But what do I have to look at? V prime, when that's positive or negative. What's V prime? A. So if you want to find velocities max or min, and you have position, this is the whole x double prime tells me about x prime situation. You take the first derivative, great. But you take the second derivative, great. Here, my second derivative, my acceleration is just 2, which means it's positive, which means my velocity is increasing the entire time, which means, and this is another situation we can have, for a fact my max has got to be at 4. I know for a fact my max has got to be at 4. Why? My max velocity has to be at 4. Why? Because my velocity is increasing consistently over my interval. The acceleration is positive. There's V. V of 1 is -4. V of 4 is 8 minus 6, which is 2. That's got to be it. Now, when is my velocity at a min? Right there. So this is fastest left. This would be fastest moving to the right. The only way you can be fastest left is if your velocity is negative. Fastest right, your velocity has to be positive. Okay? So here, x prime 3t squared minus 4, x double prime 6t. Between 0 and 3, again, x double prime or a is positive. That means v is increasing. So v of 0, which is negative 4, would be the min. Fastest left. V of 3, which is 27 minus 4, which is 23. That's going to be the max. Hopefully this is better. 3t squared minus 12t. V prime, or A, 6t minus 12. Fantastic. At 2, between 0 and 5, V prime tells me about V. So these are like good questions, but like this is a warm up for what we're about to do when we have our calculator. So like I hope we're staying with us and not thinking, oh, this is easy, because not the rest of the homework is like this. Plug in 1 negative, plug in 3 positive. So V is decreasing, increasing. I know V of 2 has got to be the min. Now if I plug in 2, I get 0. So the min is actually when I stopped. It's what do I do for the position? I'm moving to the left from 0 to 4. That doesn't make sense. Oh, I plugged this into V prime. My bad. Of course. I knew something was wrong. V of 2 is 3 times 2 squared, which is 3 times 4. And then minus, this is A, minus 12 times 2, which is 24. So I get 12 minus 24, which is negative 12. Boom. Fastest left, min velocity. Fastest right, it's either at 0 or 5. Velocity of 0, here's my velocity, it would be 0. Velocity of 5, I think I can do this. 5 squared is 25, times 3 is 75. 12 times 5 is 60. So I get 15 max. Okay, moving fastest to the right at the 5th second. Okay, same deal, x prime gives us my velocity. To find when my velocity is at a max, we look at velocity's derivative. We look at A. We look at x double prime. Or V prime. T squared minus 6t plus 8. 2t minus 6. That's a 3. X double prime, 0, 5. That's A. That'll tell me about V going up, going down. Negative, positive. V's going down, then up. For certain, I have a min. I'm sorry that I should have changed some signs of some of these so that it won't always be like this. Check your stuff. But my apologies for this. V of 3 is going to be the min. V of 3, here's V. What's V of 3? 9 minus 18 plus 5. 9 minus 18 is negative 9. Plus 5 is negative 4. Excuse me. Ugh. And then, again, I'm finding V's. V of 0 is 5. If I plug in 0, I get 5. Or that's an 8. Excuse me. V of 0 is 8. V of 5 is 25 minus 30 plus 8. Which is 3. Okay. Min, Starting point, max. I guess these are good because at least some are maxes, some are mins, and like don't assume it's because of this distance. All right, now we got stuff. Okay, these are the good questions. When are we furthest left or furthest right? I'm given a velocity. I'm given a position. Okay. Now, before we do these questions, let's start with this one. Okay. I'm sorry that I'm not going in order. But if you understand this one, then you will understand how to do the other ones. Okay. What's going on here? My dude is moving to the right until t equals 3. He's moving to the left until t equals 5. And then he's moving to the right after that. Right? You guys answered that. But now we know with the areas, we know how far he's going to the right. So we know that these zeros are important. Okay? These zeros are when we change directions. When our velocity changes sign is when our position will change directions. When my position goes from increasing, decreasing, decreasing, increasing. It is just like with f and f prime. Okay? But now we know one new thing that we will be able to apply with f and f prime. That the areas tell me how far I've gone to the right, how far I've increased. The areas tell me how far I've decreased. So this is easy to understand. What could be my max if we're talking about from 0 to 6? Okay. Well, my max position could be at 3, right? Because I move to the right, then I move to the left, then I move to the right. Here's my max. I also could have a max at 6, right? Because I end up going to the right. Okay, so I go right, left, right. I could end up in a further right position than where I got at 3. Where could be my min? Well, my min could be at 5, or it could be at 0. Why? Because I go to the right, and then I go left, and then I go right. Maybe at 0, I'll start to the left of where I end up at 5. This is the idea behind your candidates, okay? Making sure you understand we could start or end. We're checking our endpoints. Boom, we can figure out when I'm furthest right, left. All right. Now, it's so easy with these. You're told your position at time 0. It's 2. I go to the right. How much? 5. So, going to the right 5, at the 3rd second, I will change directions at the 7th meter mark, at the position of 7. Then, after 2 seconds, I will have gone left 3. So after 2 seconds, I go 7 to 4. And then during the last second, I go to the right 1. During the last second, I go to the right 4. Boom. Turns out my max to the right is this position, this time when I change directions. My min is actually where I started. It's not when I changed from going left to going right. My min is where I started. This is a perfect example. The min was not here, where it's like, oh, I know this is being min. V goes from negative positive. F prime goes from negative positive. This is my min. Well, it's actually not less than where I start. We check our endpoints. We got that. Okay. Same question, only I know x of 3 is 4. Okay, well, again, and I'm doing these first because this is so important, because it'll help us when we do the previous ones. Let's look at V sines. This is x prime sines. This is f prime sines, right? This is x prime, f prime. Cool. They are negative until 1. They are positive from 1 to 3. They are negative at the end until 4. Okay? At 3, I know I'm changing directions from right to left. Okay? Positive, negative, right to left. So, in terms of furthest right, 3 is an option. And I already know what x of 3 is. What also is an option? At 0, well, I start at a place, I go to the left. which means my starting point could have also been where I'm furthest right. That's my candidate. My other candidates for furthest left are at 1 and at 4 because I go to the left, I go to the right, and then I end up going to the left. It should make sense. Go to the left, go to the right, end up going to the left. Depending on how far we go left and right, we'll figure that out. Okay? Now, let's figure out the positions. Well, I know at time 3, I'm at 4. Well, at time 4, I've gone to the left 3. That's how I get to a position of 4 of 1, right? So I start at 4, I go to left 3, I got 1. Now, from 1 to 3, I go to the right 6. Okay, let's think about this, and you can use this formula. I know x of 3, that's 4, but I'm trying to figure out x of 1, and I know my displacement from 1 to 3. I hope we understand this. What does this mean? It's the area under your velocity. How can you calculate it? Well, use your calculator. If you don't have a calculator, take the antiderivative. If you're given the graph of v, this means it's areas. It's that simple. So x of 3 is 4. I don't know what x of 1 is, but I know from 1 to 3, I'm going to the right 6. Okay, if I go to the right 6 to end up at 4, where did I come from? I came from negative 2. I got to subtract that 6. So this is negative 2. What about at x equals 0? Well, I went to the left 2 to get to the negative 2. That means I must have started at 0. You can do whatever you want to get that, okay? Let's think. Does it work out? I start at 0. I go to the left 2. I'm at negative 2. I go to the right 6. I'm now at 4. Does that work out? X of 3 is 4. Good. I then go to the left 3. Now I'm at 1. When do I have a max or min? Here, I'm furthest right at this x of 3 equals 4. When am I furthest left? At the left endpoint, negative 2. Did it flip-flop from the last one? No. Whatever. Okay? Now, we can do this with graphs of v. Now, pay attention to your interval. Pay attention to the position you're given. Let's do this. T to the 2/3. You did this in your homework. Cos t plus 2. I'm going to graph 0. I'm going to need it from 0 to 8. What is this? The graph of v. The graph that I just saw. I'm really making it difficult on you guys a little bit. Not that difficult. Okay? What can I do? Well, I can find the locations of these zeros. I can find these areas. I'll know how much I'm moving right, moving left. I can figure out when I'm a max, when I'm at a min. Okay, I have candidates. They might be at 0 and might be at 8. Look, I moved to the left a little bit. Why? Because I'm looking at the area. The area is how far I move left. I can find that area. I'm going to. I moved to the right. How much? I can find that. But then I moved to the left a lot more. Now, my question is left, right, left. I'm thinking that 8 is going to be the min. This is my guess. Here's my hypothesis. X of 8 is going to win. And that's going to be the furthest left. Now, the furthest right, I start somewhere, I move to the left, and then I move to the right. I can see this is bigger. I think this second location right there. So I got 0, I got my first location, I got my second 0 for velocity. I think that's going to be it. Okay, so my furthest right, my guess is going to be x of this question mark. Okay, now let's go ahead and just find those. Okay, did I graph y equals 0? I did. So make sure you graph y equals 0. Second calc, let's find those intersections, and let's store those values because we're going to use them in a second. Okay, 2.712389. I'm going to store that as A. Now, on like a free response test, you got to list off what A is if you're going to use it. Okay. And then let's find the other one. I'm going to store that as B. 5.853. Store that as B. I think I'm furthest right at B. Furthest left at 8. Just make sure you list off the entire number. What was my velocity? It was negative, positive, negative. Now, what's helpful storing these numbers is the following. It's going to be nice to see, like, let's find my area. Number 7, from 0 to A. Booyah! What's that? How far I went left. I start, I have a position at time 5. Oh boy, brother. Well, at least we'll be able to know what my answers are going to be, but then like finding the positions are going to be annoying. Why did I do that? I should have given you x of 0. Okay. Well, I went to the left 2.07. Now let's find the area from A to B. Boom. That's 5, so that's how much I'm going to the right? 5.259. Great. And then let's finish off with how much I'm going back to the right, to the left. Let's go from B to 8. Negative 5.729. Is that really 5.259 and this is negative 5. Oh, I think I was. No, I'm right. I go to the left 2. I go to the right 5. I go to the left 5.7. What's going to be the furthest left? At 8. What's going to be the furthest right? It's actually going to be at the start. So we understand that my start is a candidate, right? Because I go to the left, go to the right, go to the left. What we're going to have to do, maybe like is doing this, and this helps us, but maybe watch, we can just identify our candidates and then find them, and compare them. So now after doing this analysis, I realize that I think that my start is when I go left 2, right 5. Okay, this is definitely right. But my furthest left is my start. I think that. Why did I'm getting all confused here. I go left 2, right 5, left 5.7. Could be a max at 0. Good. Could be a max at B. Could be a min at A. Could be a min at 8. Oh, furthest left I think is at A, not at 8. I think I don't go too far enough to the left at the end to counter how much I go to the right. I think these end up canceling themselves out, and I think this area is going to win out. So I actually think after doing this analysis that A is going to be furthest left. So it's not going to be an endpoint. We have to find out. How am I going to do this? I got to go back into the home screen because I have x of 5 as 3. 5 is right smack dab right here in between A and B. They made this tricky on me. Okay. So how am I going to find x of B? Well, it actually makes sense. X of B will equal my starting position plus my displacement between the two. So many of us are being very confused about, like, we do some work to get this number, and you don't know that you don't just use that number in integral. You don't just find an area. You have to find that area and use it to find a position. Okay? So that's how I'm going to find x of B. Now to find x of 0, it actually doesn't make sense to do it that way. It's going to be x of 5 equals x of 0 plus the integral from 0 to 5, and I'm going to solve for x of 0. Okay, this is what I'm trying to solve for. X of 8, this is easy. X of 5 plus the integral from 5 to 8. That'll give me my position at time 8. X of a, this one is going to be the trickier one as well. I'm going to say x of 5 equals x of a, because this is in the past, plus a to 5. Okay? And now it's helpful if you do this in the home screen, because once you have math 9 kind of in there, and you got the a's and b's, it's going to be easy to repeat. So let's go 5 to b. T to the 2/3 cos t plus 2 dt. Okay, that is my displacement from 5 to b. I know my position at time 5 is 3. So I get 4.04. I think that's going to be my max position. So it's to the right of where I started. That's good. But let's check 5. We got this from 0 to 5. Notice your calculator taking some time to do the accumulation. It's doing a lot of velocity times times. Now this is 3, and this is 2.14, so I have to take 3 and subtract the 2.14. 0.858. That's x of 0. Okay, what wins? 4.04, obviously. Let's try the left and just make sure. I know x of 5 is 3. What is my displacement from 5 to 8? So from 5 to 8, this is my other endpoint. Negative 4.687. Obviously, like, look, I'm subtracting numbers. Obviously, I was been like subtracting just a little bit, but I'm subtracting a big number here. And that gives me a negative position at time 8. And then at time 5 is what I'm trying to find, or time A. I know what time 5 is. I want to find time A. 2.713. So I want A to 5. $4.218. I know what x of 5 is. It's 3. So x of a plus 4.218. Subtract. It's going to be close. 3 minus that number. Negative 1.218. Oh, I was wrong. What am I thinking here? I don't know. X of a is negative 1.218. So I was right. Furthest left is at 8. Furthest right is at B. Is that right? I mean, it must be. I just checked my candidates. I go to left 2. I go to the right 5. I go to left. Oh, yeah. Okay. You go to left 2. You go to the right 5, but then you go to the left more than you went to the right. So you went left 2, and then I will end up going to the left between A and 8. Oh, man, my brain is fried. It's the end of the day. I'm doing this after school for you kids. That makes sense. And when am I going to be furthest to the right? I only go to the left a little bit. I go to the right a lot more. That makes sense. That makes sense. Goodness gracious. My brain is fried. I mean, I should have just like done it with the dude. Okay. But like wherever. Let's pretend I start here at time 0. I go to the left 2. I go to the right 5. I go to the left 5. But I go to the left more than I went to the right. Go to left, go to the right 5.2, go back to the left 5.2. Boom. I'll end up at a minimum. After I've gone to the right, that'll be my max. After I gone to the right, B, that's my max. Where do I end up at a minimum? Yeah, that's tricky. All right, another one. Told my wife I wasn't going to be home until like 5:45. And she said she could get the kids. Look at us, adjusting and adapting because I had a department chair meeting and I could not make the video this morning. I hope this is easier than the last one. The last one, the ones with, okay, at least x of 0 is 4. That's nice. I mean, x of 0 is 3. They give me x of 0. So that means finding those areas is going to help me. I'm only going from 0 to 4. Let's hope we don't have 2 sign changes. I feel like we will. There's 1. There's 2. Don't tell me we have 3. Okay, this is good. And this is also interesting. I go to the left a little bit. I go to the right a bunch. I go to the left a bunch. I don't know how much I go. So let's understand that we got a negative. We'll call this A. We got a positive. We'll call this B. And then we're back to being negative until 4, starting at 0. We have candidates. A is a min when I'm furthest left. That will just be x of 0, which is 3, plus my displacement, which I'll be able to find. And we can use x of 0 every time. The other candidate for furthest left is at 4. So x of A and x of 4. I know that. Furthest right. And literally every single time I'm going to be using x of my number that I'm trying to find equals x of 0 plus my displacement from 0 to my number. So just so you know, I don't have to worry about the crazy things where it's like future, past. Starting with x of 0 is 3. I gave something that's nice to you. Furthest right. I could start furthest right because I start going left, and then I could end up furthest right at B because this is when I change directions from right to left. Okay? So these are my options. Let's find these intersections. This one's at 1.989, so B equals 1.9892214. So make sure you write that whole thing down, and let's store that as B. That's now B. It will override our previous B. And then let's find our other intersection, which is at like point something. Moving to the y equals so it's easier to get there. Enter, enter, enter. 0.145, so that's A. Use that entire number. Now you know what A is, blah, 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 blah. And then x of 0. I know that. That's 3. You can find the areas. Second calc, the area from 0 to A. This is telling me how far. Oh, I didn't store that. Sorry. X is that. Second calc intersect. Do they have this as a graph of E? No. Or A accumulation? Forgot to store this number. Store it as A. feel like I want to regraph. Maybe click that off, click that on, and it regraphs. Yeah, there we go. Now let's find the areas. And let's see, like, oh, I've gone left this much. It's a tiny bit. And then I go to right a bunch. And then I go to left even more. So let's see. And let's use our guy because it won't screw it up in my brain. 0 to A. All right, I go to the left just 3.43. 0.343. I barely go to the left, okay? And let's figure out how much I go to the right. From A to B. I go to the right 9. And then B to 4. I go to the left 8. Okay, I got this one. Ready? The dude started somewhere. That's now only negative 8.1. Here's my dude starting somewhere. He went to the left a teeny tiny bit. Then he went right 9. And then he went left 8. When he gets to A, he's furthest left. When he gets to B, he's furthest right. It does not include an endpoint. Okay? Turns out this area here is actually less than this area here, which means my displacement is less. And let's see how that plays out. In my home screen, I will do the following calculations over and over and over again. X of A is x of 0 plus my displacement from 0 to A. 40 e to the negative t sine t minus 5. Enter. 2.656. Just to the left of where I started at 3. Let's find my position at time 4. I will do the same thing, only I can find my displacement from 0 to 4, my change in my position, so I don't have to worry about like going one at a time and then use this position to find the next position, though I could. 3.5166. Now let me show you how I can get that as well. Like I can go from 0 to A and then to B and then to 4. I'll do that in a second. But let's do B. So 0 to B. 11.665. Yeah. Furthest left, winner. Furthest right, winner. How do I know that? I understand motion. I understand the areas. I found the areas in between everything. That's great. Watch how I can get these numbers one at a time. Ready? We start at 3. Let's find A. So 3 plus, let's just do it here. 3 plus the displacement from 0 to 3. From 0 to A. Let's find A. Okay. Now let's go from A to B, and then we'll go B to 4. So we're just like doing this, subtracting 3, adding 9, subtracting 8, okay? So now this position is my position at A, and then I'm going to add this integral, subtract that 3, but from A to B, right? This is me adding that area from A to B so that I'll get this 11.665. Boom. Okay? Now let's find 4. Well, I know my position at B. Let's subtract the 8. Well, add this integral, but from B to 8. B to 4, subtracting the 8. Boom. There's that 3.5166. Okay? So other ways to do this Either you could like just literally add those numbers. If you write them out, it's annoying. You can use this every single time because this is telling you you're changing your position over the interval. So many ways to figure this out. All right, two more. Oh, we did this one in class. Let's just do it again. 0 to 7, t sine t. T sine t does not grow too quickly, so I think I'm going to adjust my window. 7 is big. Let's just see what happens. That's fine. That's perfect. Again, I hate myself, so I gave you 2 times when I change position, but I have a good idea. Now I'm gonna just go ahead and tell you, like, when does t sine t equal 0? Pi, 2 pi, when sine is 0. Now, can you check that? That's pi, 3.1415. And I'm not even gonna bother doing it for the other one. Okay, pi, 2 pi. So let's just go for it. Okay, we got 0, we got pi, we got 2 pi, and we got 7. I'm telling you a position at time 4. Thanks, Mr. Messner. Maybe I don't know. Maybe I don't find the positions and compare them just to double check. Maybe I just know based on my Maybe for this one I will. Okay, but then I want the positions there. So my velocity is positive. I'm going to the right. Then it's negative a lot, and then it's positive. I'm fairly certain I'm furthest left at my position at 2 pi. Now that's easy to find because I can just take 4 and then find my displacement from 4 to 2 pi. Okay? So I don't have to worry about that. I go to the right a little bit, left a lot. I don't think I'm going to go to the right as much as I go to the left. So let's just do some work here. Second calc, let's find our areas from 0 to pi. I'm going to increase or go to the right pi. That's great. And then from pi to 2 pi, I wonder if it's going to be 2 pi. Lower limit from pi to 2 pi. It's my upper limit. I'm used to plugging A and B in, but whatever. No, that's a little bit more. So I go to the left 9.42. I go to the left a lot. And let's go from pi to 7. Ooh, that's a lot. Left 7.76. All right, so let's think about it. Dude, I go to the right 3. I then go to the left 9. But then I come back to the right 7. Okay, all right, I think I'm good. I think that at pi, that's going to win, and 2 pi is going to lose. Or 2 pi is going to be my least. Okay. When I go to the right to get my max, I'll have the max. When I go to 2 pi, I'll have the min. And I'm definitely certain about that. Sorry, this should be right 7.76. Because the difference between these is not pi. So anyways, let's just find that. And I'm probably going to find them all just to confirm. X of pi. Now, to find x of pi, I'm going to have to flip-flop things. Okay. Find x of 0, same thing. And that's going to be a candidate for furthest left because I'm going to the right. So this is x of 4 equals x of 0. And then the right would be 7, but I know that's not going to be. I go to the right. Um, I go to the left so much, I do not go to the right as much, so that pi is going to win. Pi is going to win, 2 pi is going to win. Let's just double check that. I'm going to be home later than that. All right. X of 4 is negative 2. Let's just have the integral laid out. That way we can kind of manipulate it however we want to. 4 to 2 pi is what I'll start with. I don't know what I just typed in. 2 and pi. T sine t. That's easy. dt. All right. So negative 2 plus that. Yeah, if I start at negative 2, I go to the right just a little bit. I go to the left 9. Boom, negative 10. I go to the right pi, so that makes me 1, and then I go to left 9. Oh, no. Sorry. At t equals 4, which is right here. This is the position I know. So don't think about that. I'm going to the left some amount from negative 2 to get to that. I'm sorry, I'm not giving you x of 0. All right, so we're good. Just stick to the calculations. Let's do 4. 0 to 4. Oh, I guess I'm doing 0. 1.8577. This is negative 2. This is x of 0. This is 1.857. You're going to have to subtract that to get x of 0. So negative 2 minus that. Negative 3.85. This one works out, but not pi to 4. I really screwed you guys over by giving you this crazy thing and giving you things with like multiple candidates. I think it's easier on your actual test. It's negative 1.283. So I'm going to take negative 2 and add that number or subtract that number. So negative 0.716 is x of pi. Still negative, but so far it's the winning candidate. And let's do 7. This one works out nicely. 4 to 7. And I know x of 4. X of 4 is negative 2 plus negative 6 point something. Negative 8.47. All right, so which wins? Yep, furthest right, furthest left. I checked just because. Did I have to? No. If you understand movement, you'll be fine. I'm just understanding movement. Okay, I'm not going to find the positions for this last one. I mean, maybe I guess I will. If it changes sign twice, I'm upset at myself more than anything. I know why I did this. Okay, because this is like good practice. I didn't even give you an interval. I'm going to tell you to skip this one. Let's just look at it. Let's see if it's like from 0 to 4. Oh, don't change that again. It's going to come back and change that. All right, hey. It's got to be 0 to 4. That's fine. Let's go 0 to 4. This is easier. Yeah. Okay. Boom. 0 to 4. Hooray. Thank goodness. What happens? My velocity is positive and then negative. Where is it going to be furthest right? Obviously, my position is going to be furthest right here at this value. When is it going to be furthest left? I know I'm going to be traveling a lot further to the left than I'm traveling to the right. So I will end further to the left of where I started. I'm going to start somewhere. I'm going to go to the right some, but then I will be going to the left more than how much I'm going to the right. So 4 is going to win. A is going to win. Let's just find A, find 4, and call it. (2.06102). Store that as A. X. Store it as A. All right. So furthest right is X of A. I will find that in a second. A to 4 of t squared cos t plus 2. I'll take negative 4 and I will add that. So, take negative 4, add that, subtract the negative. Okay, 7.988. I should have listed off what A is equal to. 2.0610. 26234. Okay. And then furthest left is going to be at my endpoint, X of 4. X of 4 is negative 4. I win. I can easily check X of 0 though. My displacement from 0 to 4 is negative 7.824. Okay, what does that mean? That means I ended up 7.82 units to the left of where I started. I started somewhere where my displacement between the two was 7.82 units to the left. This is negative 4. I add that by subtracting it, doing the opposite. I get 3.824. Okay. So left, obviously, X of 4 is negative 4 wins. All right. Let's finish this off. Great. Do all. I'm blowing through this, okay? Left 8, right 3, left 2. What am I furthest to the left? My furthest to the left is X of 3. What's the position? I started at a position of negative 2. I went to the left 8, so negative 2 plus negative 8 is negative 10. The only other candidate is X of 6. You can literally just list off all your candidates when your derivative equals 0. I'm not going to worry about justifications for this. Like, your other candidates are technically 5, and your position is going to be negative 7 and 6, and your position is negative 9. How do I know that? I go to the left 8, so subtract 8, and then add 3, and then subtract 2. Boom, these are my positions. you can literally just say candidates. If you've listed off all the candidates, you've listed off when your velocity equals zero or the endpoints, and you have to just provide that x of zero is -2. Boom, furthest left. All right, well, how many times is the particle -8? Well, if it goes from -10, if it goes from -2 to -10, and this is tricky, it's not that tricky. If x of 0 is -2, if x of 3 is -10, if x of 5 is -7, and x of 6 is -9, and your velocities are consistent in their sign, which means we're moving left, we're moving right, we're moving left, in between these values, then we're going to have to cross -8 once, twice, 3 times. Why does it have to be consistent? That way we're not going from -2 to -9 to -7 to -10. If that would have happened, your velocity would have hit another 0. 2 to 3, speed of the particle increase or decreasing? It's decreasing. The absolute value of your velocity values are decreasing. That's one way to say. Or you could say V is negative, A is positive. The signs of V and A are opposites. Boom. When's the acceleration of the particle negative? Since you know acceleration is equal to the slopes of velocity, you could say either when the slopes of velocity are negative or when the velocity is decreasing. That's your justification. You have to say that, though. It's like when V prime is negative, the slopes of V are negative, or when V is decreasing. That's going to be from 0 to 1 and 4 to 6. Done. I think the other question is also quick. Why do I give you a lot harder questions than actual free response questions? Oh, all right. This is a good one, guys. Look, we're moving on the y-axis. Is that freaking me out? No. Instead of moving right and left, I'm moving up and down. Okay? Moving up and down. Highest point would be like a max or when I'm furthest right. At time t equals 0, the particle's at a y coordinate. You can flip this so it's on the x-axis, so it's fine. You could say x of 0 is -1 or y of 0 is -1. Like either of these are fine. Now, unfortunately, my velocity is 1 minus the tan inverse of e to the t. And I don't really have an interval. So I'm assuming that things are going to work out nicely. Oh, the jerks. Okay. What you can't see is what I see, which is that it's a little bit positive, then goes negative. I'm going to shrink my Y window. Oh, this is like zoom fit, right? Is that what it is, zoom fit? Yeah, so like it hips me up with the max Y and the min Y. Change your window for X's, zoom fit for Y's. I think Dorler taught me that. You are in here for eternity. Okay, the acceleration at time 2. Now remember, A is V prime. V prime at 2. I have V. How do you find the derivative? Well, you could try to take the derivative. Don't want to do that. Do you remember how you can second calculate the derivative? I do. Do you remember how you could do it either here or you could do it in your home screen using Math 8 and derive? Remember what your calculator does to get this? It uses a slope formula of 2 points really, really close together, 1/1000th away from each other, I believe. Boom. That's the acceleration. It's negative. Part B is the speed at time 2 increasing or decreasing. Well, you can see my velocity values. You can either say the absolute value of my velocity is decreasing. Oh, no, sorry. My velocity values are getting more negative. The absolute value of velocity is increasing. So speed is increasing. I don't know if they'll accept that. Why don't we just stick to v of 2 is negative? Why is that? If this is velocity, that's a negative value. And we already know a of 2 is negative. So the signs are the same. We're going the same direction. Speed is increasing. Your velocity values are negative, getting more negative. I don't know if they'd accept that. I have to talk to Faker about that. When does the particle reach its highest point? That's it. That's the max. To justify this answer, though, it's like they're so tricky. The max is going to be when v equals 0. Uh, uh, no, let's just go straight to it. Let's find this value, and I'm gonna do the the easiest justification in the world. The max is at t equals 4.443. Okay, and include it. Blah blah blah. Why? Because v is positive for t's less than 0.443, and v is negative for t's after 0.443. It's like, this is my only candidate because I'm moving to the right strictly, and then I'm moving to the left strictly. Okay? And I don't even have an ending. Now, what is my position? Oh, I don't even need to find the position. Okay? That's it. The max is at this time because I'm moving, the particle is moving up strictly, and then the particle is moving down strictly. Or you could say my position is increasing strictly, my position is decreasing. Find the position of the particle at t equals 2. Great. X of 2 equals x of 0. Sorry, we're on the y-axis. Y of 2 equals y of 0 plus my displacement. You can find your displacement and then just add it to -2. But like when you do that, you have to write it down. You can see it. Like I'm definitely moving to the left, actually moving down more than I'm moving up. So I'm going to end up at a fairly negative position since I start at -1. Let's just figure that out. Math 9, 0, 2, 2. I have the position at time 0. It's -1. Good. Of velocity, 1 minus tan inverse e to the t. That's my displacement. Subtract that from -1. I mean, don't subtract that. Like, add that negative number. Okay, so y of 2 equals -1.360. Is my particle moving towards or away from the origin at t equals 2? Well, my position is negative, which means I'm to the left of the origin. My velocity is negative. I found that earlier. Therefore, I must be moving away. You want me to justify my answer? My position and velocity are both negative. All right, I'm out. Sorry for all those crazy examples. You gotta understand this. Like probably the most important part of this homework was, understanding this question here, and this question here, and then being able to understand how it's the same as this question. You just got to do a lot more work, a whole lot more work. All right, I'm out. Later.